My name is RM Jan Adam B. Manceras, and my assigned topic is Explain Geometric Patterns and Symmetry. So what is geometric patterns? Geometric patterns refers to repeatedly shapes, designs, or structures that follows a specific mathematical rules. They can be created using points, lines, angles, and other geometric elements. So here's some example of it. So as you can see in my examples, geometric patterns are shapes, lines that repeat to create designs. In math, geometric patterns are a way to represent numbers, patterns visually. To continue geometric patterns, you can identify the rule that governs the patterns. You can even use geometric patterns to find a missing number in a sequence. So symmetry and geometry refers to a property where a shape or design can be divided into two parts that are identical or correspond to each other in a balanced way. This can be reflected across inline or reflective symmetry, rotate around a point, rational symmetry, or even scaled dilation symmetry. In my example, symmetry is a sense of balance, order, or proportion that can be found in nature, art, and math. It can also be used to describe the orderly arrangements of atoms and chemistry. In math, symmetry is a property of an object that can be divided into identical halves or a mirror image. So guys, that is geometric patterns and symmetry, and hope you learned something, and goodbye.
What is reflective symmetry? Symmetry is when something is identical to its half. If we take a look at the yellow butterfly, divided it in half down its middle, we could see that its wings are the same. They have symmetry. If we were to divide the orange butterfly in half down its middle, we would see that its wings is not the same size or the same shape. The orange butterfly is not symmetrical. It does not have symmetry. In this video, to see if something is symmetrical, we need a reflective surface, like a mirror. In this case, we have a mirror and a piece of paper. We're placing the mirror down the center of the piece of paper. It doesn't match up right away, so we're going to have to keep rotating the paper until its reflection match up. When it's opposite side, once that happens, we know that we found the line of symmetry. We can also determine if the paper has symmetry by folding it in half and knotting edges once we fold the paper. We can more clearly see the symmetry. A line of symmetry is an imaginary line that passes through the center of the paper and divided it into identical halves.
So let's move on to the second type of symmetry, which is the rotational symmetry. Rotational symmetry occurs when a shape or pattern looks exactly the same after being rotated by some degree about a point. We count rotational symmetry by the number of turns it takes for a shape to look the same in a full turn. This is called the order of rotational symmetry. So I have here the example of rotational symmetry. Let's see if it has rotational symmetry, and if so, what is the order of rotational symmetry of this square? The number of times it will look the same when rotated 360 degrees around its center point. You can mark off as a reference point on the shape that you can use to keep on track of. As we rotate the square, we can see it looks the same in four different positions. When the reference point ends up back, at the starting position. Therefore, it has rotational symmetry, and this square, it has the order of 4 rotational symmetry.
Good day everyone, my name is Katrina Silo and today my topic is all about translational symmetry. But first, what is translational symmetry? So, translational symmetry, it is when something has undergone a movement, a shift, or a slide in a specific direction through a specific distance without any rotation or reflection. Or in other words, translational symmetry is a moving a shape to a new location. So we have here an example. So the first example is a honey house or honeybee house. So as you can see in the picture, it has a shape like a piatos. So that shape is repeated in an axis. So it has a pattern, it has also have an identical parts or slides. Even if you look onto other sides, it has asymmetrical shapes, and that's what we called translational symmetry. So the other example of translational symmetry is wall bricks. So a wall bricks exhibit a translational symmetry because the pattern or bridge remains the same. When you slide or translate it along the wall in any direction, meaning you can move your viewpoint along the wall and see eventually the same arrangement of bricks throughout the structure. Each brick is positioned identically to the next in the patterns, creating a repeating design. So, in other words, wall of bricks is translational symmetry because it has a repeating.
Everyone, good morning. My name is Richard Riston. Today I will discuss the isometry. To proceed the discussion, let me read these 4 objectives. First, definition isometry will define isometry precisely distinguished from other transformation that alter shape or size. And second, types of isometries. We will explore those 4 main types of isometries: the 2-dimensional space, translation, rotation, reflection, and guide reflection. A fundamental concept in geometry that describes a transformation that preserves distances between points. In simpler terms, it's a way of moving an object in space without changing its shape or size. Imagine a rigid object like a roller. If you slide it or rotate it or even flip it over, it remains the same length and shape. These movements are all examples of isometries. There are 4 types of isometries. First is translation, second is rotation, third is reflection, and the last one is glide reflection. Translation means shifting an object without changing its orientation. This is like sliding a book across a table. Rotation means turning an object around a fixed point. Imagine spinning a coin on a table. Reflection means flipping an object over a line. Think of holding a mirror onto your face. And the last one, glide reflection, means a combination of reflection and translation. Imagine sliding a book across the table and then flipping it over the table's edge.
So, good morning everyone. I am Yana El Sumbilia from Block D. And now we are going to talk about geometric, symmetry, and isometry. So, to conclude, in geometry, symmetry refers to a figure having a property where it can be transformed into itself by a specific geometric operation like rotation or reflection, while isometry is a geometric transformation that preserves distance between points. Essentially, meaning it moves a figure without changing its size or shape. A key point is that a symmetry is always considered an isometry as it maps a figure into itself while maintaining distances. So now let's talk about the symmetry. Rotational symmetry. A shape exhibits rotational symmetry if it looks the same after being rotated around a central point by a certain angle. The number of times it matches its original position in a full turn is called its order of symmetry. Next is transitional symmetry. Transitional symmetry occurs when a shape is moved or shifted in a specific direction over a certain distance without rotation or reflection. This movement is known as translation. The third one is reflective symmetry. Reflective symmetry or line symmetry happens when a shape is mirrored over a line, creating two identical halves. If folded along this line, the halves align perfectly. Now, let's proceed to isometry. Isometry refers to transformations that preserves distance and shape, keeping the object unchanged in size or form. Types of isometries include translation, rotation, reflection, and glide reflection. So, translation, sliding an object without rotation. Rotation, turning an object around a fixed point. And reflection, flipping an object over a line. And the last is glide reflection, a combination of translation and reflection.